In the last couple of videos, we've been talking about light as a wave, but in this video, we'll be looking at light as a particle. So, our double slit experiment, if we get it up, we can see our points of maxima in this. This is when we shine the laser directly at our double slits. The laser is a very strong light source. What happens if we only have a very dim light source? So, if we have a very dim light source and we go through these double slits, we get this pattern happening. There's not much of a pattern, it's more of a random distribution of these light specks. If we increase this very dim light very slightly, we get to have more of these specks on the screen. If we keep on increasing the intensity of our light that we're shining through the double slits, we eventually end up with our pattern that we know. So, if we only have the very dim, very low energy light that's going through these slits, we only get these few points of light showing up on our screen. And when we increase our light, we get this pattern that we know from the double slit experiment. So, each of these little specks that we see on the screen are photons, the little energy parcels of light. Now, for this to work, light is working as or behaving as a particle, because we get defined points. So each of these parcels of light that we just saw on the screen have a certain energy. This energy can be defined by the equation E is equal to hf, where h is Planck's constant. Planck's constant is 6.63 times 10 to the negative 34 joule seconds. So E is equal to hf. That's a formula you need to know how to use and how to rearrange to find out information. So, E is equal to hf is the energy of our photons. If photons are behaving as particles, they need to follow the same conservation laws that any other particle in motion does. So, the conservation of momentum needs to be conserved. So, momentum must be conserved. So, the conservation of momentum must be followed. So, to find out the momentum of our particles, if the energy is equal to hf, and our energy can be worked out using Einstein's famous equation E is equal to mc squared, where c squared is the speed of light squared. So if we have mc squared is equal to hf, if we then rearrange this formula to get m by itself, we get m is equal to hf divided by c squared. Now, the wave equation, V is equal to f lambda. If we get f by itself, we get f is equal to v on lambda. So if we substitute this in for f, we get m is equal to h v divided by c squared lambda. Now, if we cancel out these extra speed of lights that we have, so the v and our c, so if they're both the same particles, so they're both going to be moving at the same speed, which is the speed of light in this case, the photon being a light particle. So we get our m is equal to h on lambda. So if our mass is equal to that, and we substitute this in to the formula P is equal to mv. So we get that P is equal to h divided by c lambda times by the speed of light again, so c. So if we cancel out these c's, we get that P is equal to h on lambda. So this is another formula you need to know. P is equal to h on lambda. So the momentum is equal to Planck's constant divided by the wavelength. So the key points from the video. This is going to be a very short video today. So, key points. We have particles of light. These particles of light are called photons. Photons have an energy, E is equal to hf, and they have a momentum, P is equal to h on lambda. So to see how to use the equations, you need to watch the live scribes. So, photons are particles of light, and they have energy equal to hf, and momentum equal to h on lambda.